Question 1a. Determine number of ways to form 5-letter word from the word absurdity if the letter must start with the letter D and end with the letter Y. 1 come from the letter D and Y. 7 come from the word ABSURIT and times 6 because the letter is not repeated and times 5. So the answer is equal to 210 ways. Question 1b. Determine number of ways to arrange the letters in the word obsoletely such that the consonant must be together. First step, we divide the consonant and the vowel. 5 factorial comes from the word consonant we calculate as 1 letter and also the A as 1 and also OUE. Times 6 factorial comes from the consonant that have 6 letters and divide by 2 factorial because we have 2 L in the consonant. So the answer is 43,200 ways. Question 1c. Suppose that there are 20 batteries in a box. 16 of the batteries are new while the remaining batteries are already used. A man wants to take 5 batteries from the box. Find the probability that he will get at least 3 used batteries. First step, find an sample space equal to 15,504. Let A equal to at least 3 used batteries, so we can find NA 4C3 times 16C2, which is 4 is already used and 16 is new. 4C4 times 16C1, because question asks us to find at least 3 and the used battery only have 4 batteries, so NA equal to 496. Final step, we can find the probability NA divided by NS equal to 31 over 969. Question 1d. 54 secondary school students enter a science quiz where it is found that number of female contestants doubles the number of male contestants. Among the contestants, 22 are school perfect, of which only 3 are male. A student is selected at random and calculate the probability that the student is not a school perfect and is a school perfect given that she is female. Number of female doubles the number of male. 54 we can divide by 3 and get a male is 18 and female is 36. We can get all the information given from the question to the table. Question gives 22 as school perfects and only 3 male. So we can fill the table, and 54 minus 22, we know that not school perfect is 32. And male from not school perfect is 15, from 18 minus 3, and the female is 17 for the not school perfect. So the first Roman, let A equal to is not a school perfect and 32 divided by 54. And the information is come from the table just now, so the answer is equal to 16 over 27. Second Roman, a school perfect given that she is female. So at this case, you can use a formula conditional probability, which is PH, given that F equal to F intercept H divided by F. So the answer is 19 over 36.
A. Draw a tree diagram to represent the above situation. As we can see, the probability that Lily will go to restaurant P, Q, and R are 0.32, 0.23, and 0.45 respectively. The probability that Lily will choose steak and chicken chop at restaurant P are 0.89 and 0.11 respectively. The probability that Lily will choose steak and chicken chop at restaurant Q are 0.64 and 0.36 respectively. And lastly, the probability that Lily will choose steak and chicken chop at restaurant R are 0.52 and 0.48 respectively. B. On a random Friday night, find the probability that Lily will order a chicken chop. To find the probability that Lily will order a chicken chop, we need the sum of probability P, Q, and R multiplied by probability S prime, which is chicken chop. As we can see, 0.32 times 0.11 plus 0.23 times 0.36 plus 0.45 times 0.48. As we can see, the probability that Lily will order a chicken chop are 0.334. C. Given that Lily ate a steak on a particular Friday night, calculate the probability that she went to restaurant Q. Firstly, we need to find the probability that she will order a steak. So we use the same method as before, but we change the chicken chop to steak. So as we can see, 0.32 times 0.89 plus 0.23 times 0.64 plus 0.45 times 0.52, which we will get 0.666. Then, to find the probability that she went to restaurant Q, we need to find the probability that she will order a steak at restaurant Q. multiply with probability she will go to restaurant Q, then divide it with the probability she will order a steak. As we can see, 0.64 times 0.23 divide with 0.666. So we will get the probability that she went to restaurant Q are 0.221.
I will explain about solution for question 3. The question is about a random variable x has the following probability distribution, and that is the table of the question. For A, the question asks to show that variable m equal to 5. The way to solve is the total of probability distribution in the table must equal to 1. So I just make the equation that plus all the probability and equal to 1. So solve it properly and we get the value of m is equal to 5. Next, for B, the question asks me to find Px greater than or equal to 3. Firstly, I complete the table. We substitute the value of m to get the real value for x, 3 and 4. Next, the meaning of Px greater than or equal to 3 is Px equal to 3 plus Px equal to 4 and plus Px equal to 5. So I just plus that 3 probabilities, which is 0.42 plus 0.35 plus 0.05, and the answer is 0.82. For C, I need to find the variant x and variant 4 minus 3x. Firstly, I need to find the mean with formula x times fx. So I get the mean is 3.12. For the second step, variant x, we just follow the formula that ex square minus total of ex square. And the value of variant x is 1.1656. Next, for variant 4 minus 3x, I need to simplify with the concept that variant 4 plus negative 3 square times variant x. I know that variant 4 is equal to 0, so solve negative 3 square and we get 9, and times with variant x, which is 1.1656, and the answer is 10.4904.
For question 4, the probability density function of a random variable x is given by f of x equals to k times 1 minus x squared for the limit from 0 to 1 and 0 for elsewhere. This question is the continuous probability distribution, so we will apply the integration to solve our question. To solve A, firstly we need to use the condition where the total integration of f of x dx is equal to 1. For this question, we can write as the integral of 0 to 1 of the function k times 1 minus x squared dx equal to 1. K is the constant, so we can put the k out in front of the integral. Secondly, we can integrate 1 minus x squared dx, and it will be x minus x cubed over 3 on the range 0 to 1 equal to 1. Then we can replace the x with the values of 1 and 0 respectively. Thirdly, we subtract the value of 2 over 3 and 0. Fourthly, we will get 2 over 3k equal to 1, and the value of k will be 3 over 2. Next, to solve B, firstly we make it into an integration form where it will be the integral of 0.2 to 0.6 of the function of 3 over 2 times 1 minus x squared dx. 3 over 2 is the constant, so we put it out in front of the integral. Secondly, we can integrate 1 minus x squared dx, and it will be x minus x cubed over 3 on the range 0.2 to 0.6. Then we can replace the x with the values of 0.6 and 0.2 respectively. Thirdly, we subtract the values of 66 over 125 and 74 over 375. Fourthly, we will get 124 over 375. Then we multiply with 3 over 2, and we will get the answer of 62 over 125. Lastly, to solve C, firstly we need to find ex, where the formula is the integral of negative infinity to infinity of x multiplies the function f of x dx. For this question, we can write as the integral of 0 to 1 of x multiplies the function 3 over 2 times 1 minus x squared dx. 3 over 2 is a constant, so we put it out in front of the integral. Secondly, we can expand the function into x minus x cubed dx. Thirdly, we integrate it, and it will be x squared over 2 minus x to the power of 4 over 4 on the range 0 to 1. Then we can replace the x with the values of 1 and 0 respectively. Fourthly, we subtract the values of 1 over 4 and 0. Fifthly, we will get 1 over 4. Then we multiply with 3 over 2, and we will get ex equals to 3 over 8. We also need to find ex squared, where the formula is the same with ex, but we need to multiply the function f of x with x squared instead of x. Firstly, we can write as the integral of 0 to 1 of x squared multiplies the function 3 over 2 times 1 minus x squared dx. 3 over 2 is the constant, so we'll put it out in front of the integral. Secondly, we can expand the function into x squared minus x to the power of 4 dx. Thirdly, we integrate it, and it will be x cubed over 3 minus x to the power of 5 over 5 on the range 0 to 1. Then we can replace the x with the values of 1 and 0 respectively. Thirdly, we subtract the values of 2 over 15 and 0. Fifthly, we will get 2 over 15, and we multiply with 3 over 2, and we will get ex squared equals to 1 over 5. Lastly, to find variance, we need to subtract ax squared and ex to the power of 2. Firstly, we need to find ex to the power of 2, which is a bracket of 3 over 8 to the power of 2, and we will get 9 over 64. Secondly, we subtract the values of 1 over 5 and 9 over 64. As a result, we will get the variance with the value of 19 over 320, or 0.059375.